Calculus examples, logarithmic differentiation. This is video 31, example 9. Using the alternative technique, find the derivative of y equals sine cubed of x divided by x plus 3 to the fourth. To review the above videos, you should pause this video now. All videos have been written and produced by Michael J. Bankhead. Example 9. Using the alternative technique, find the derivative of the function y equals sine cubed of x divided by x plus 3 to the fourth. Solution. The function is: Step 1. Apply the verbal form of the alternative technique. The derivative of y is dy by dx equals. The right-hand side of y is this expression, so substitute. Multiplied by is times. The derivative of is d by dx of. The line of is line. The right-hand side of y, as before, is this expression. Step 2. Bring down. Use the laws of logarithms to simplify the line function. From reminder 2 in scene 4, since x is sine cubed of x, line of x is line of sine cubed of x. Minus is minus. Since y is x plus 3 to the fourth, line of y is line of x plus 3 to the fourth. Bring down. From reminder 2 in scene 4, since y is 3, replace y with 3. Since x is sine of x times line of x is times line of sine of x. Minus is minus. Since y is 4, replace y with 4. Since x is x x plus 3 times line of x is times line of x plus 3. Bring down. Using the distributive property, this derivative can be written as the difference between these two derivatives. Do not forget these brackets. To review the above working, you should pause this video now. Write the last equation in scene 2 as Step 3. Bring down. Evaluate both derivatives using the verbal form of the chain rule for y equals line of f of x. Bring 3 down as 3 times. This derivative equals the derivative of the argument of line is the derivative of sine of x, which is cos of x. Divided by is divided by the argument of line, as before, is sine of x, and 3 times cos of x divided by sine of x is equal to 3 cos of x divided by sine of x. Minus is minus. Bring 4 down as 4 times. This derivative equals the derivative of the argument of line is the derivative of x plus 3, which is 1. Divided by is divided by the argument of line, as before, is x plus 3, and 4 times 1 divided by x plus 3 is equal to 4 divided by x plus 3. Call this equation equation 1. Step 4. Since equation 1 can be simplified, it must be simplified. Bring down. Since the denominators are sine of x and x plus 3, separate out sine of x. Sine cubed of x becomes sine squared of x times sine of x. Bring down. Now multiply sine of x by x plus 3 divided by x plus 3. x plus 3 to the fourth times x plus 3 is x plus 3 to the fifth. Bring this entire bracket down. Therefore, dy by dx equals bring down. This expression times this quotient is this expression. Cancel sine of x with sine of x. Minus is minus. This expression times this quotient is this expression. Now cancel x plus 3 with x plus 3. Final statement. To review the above working, you should pause this video now. Reminder 1. The function is apply equation 3, bring down. The right-hand side of y is this expression, so substitute. Multiplied by is times. The derivative of is d by dx of. The line of is line. The right-hand side of y, as before, is this expression. Reminder 2. To review the above reminders, you should pause this video now. Reminder 3. The derivative of p is found using the verbal form of the chain rule in equation 4. When then sine of x is the argument of line, and dp by dx equals bring 3 down as 3 times. The derivative of is d by dx of. The argument of line is sine of x, so substitute sine of x. Divided by is divided by. The argument of line, as before, is sine of x equals bring down 3 times. This derivative is equal to cos of x. Bring down. Therefore, dp by dx equals 3 times cos of x divided by sine of x is 3 cos of x divided by sine of x. To review the above reminder, you should pause this video now. When solving questions from your textbook similar to the example in this video, you should display scene 2 followed by scene 3, so you can use them as templates to find the derivative. If you want to find the derivative of y using logarithmic differentiation, then you should display scene 5 followed by scene 6 in video 29, so you can use them as templates to find the derivative. You can then compare logarithmic differentiation with the alternative technique. You should then find this topic simple and beautiful. Cheers. Do not forget to check your answers with the answers in the back of the textbook. This is the last video in the logarithms sequence. The next topic is trigonometric functions. The alternative technique formula, scene 4, equation 2, and the verbal form of the alternative technique, scene 4, equation 3, can be used to find the derivative of a function instead of using the product rule, quotient rule, chain rule, or logarithmic differentiation. This is demonstrated in the videos that form the trigonometric functions sequence. To review this scene, you should pause this video now.